What if your parking system could update available slots in real time and show it on your phone or any web browser, no matter where you are? Now, we have already built a smart car parking system using an Arduino A7 segment display to show available parking slots, and another with a 16 by 2 LCD display that allows us to display more detailed information, not just the numbers, but also text such as parking full or welcome. But today, we are taking that project a step further, making it cloud-based using an ESP32 and OLED display for a better visual output. In this project, we are building a cloud-based smart car parking system using ESP32 Wi-Fi microcontroller, OLED display 128 by 64 I2C, 2 IR sensor for entry and exit detection, servo motor to control the parking gate, some jumper wires, breadboard, USB cable, and a smartphone with a web interface to monitor available slots live. It's smarter, more connected, and takes parking automation to the next level. Let's wire up the components to the ESP32. Check your breadboard and ESP32. Connect the VIN pin of ESP32 to the positive rail of the breadboard. VIN provides the same voltage as the USB input, typically 5 volt, and is useful for powering other modules. Connect the GND of ESP32 to the negative rail of the breadboard. Take your first IR sensor for vehicle entry detection. Connect VCC pin of the IR sensor to the positive rail, GND pin to the negative rail, out pin to GPIO 18 on the ESP32. This is where ESP32 will read high or low based on object detection. Take your second IR sensor for vehicle exit detection. Connect VCC to the positive rail, GND to the negative rail, out to GPIO 19 on the ESP32. Identify the 3 wires of the servo. Brown or black as ground, red as power, yellow, white or orange as signal wires. Now connect the brown wire GND to the negative rail. Connect the red wire VCC to the positive rail. Ensure this is 5 volt if your servo needs it. Connect the signal wire to GPIO 25 on the ESP32. This pin will be used to send angle or position signals to the servo. Carefully insert the OLED module into the breadboard. Connect the pins as follows: GND to negative rail, VDD to 3.3 volt pin of the ESP32, SCL or SCK to GPIO 22, SDA to GPIO 21. These are the default I2C pin on the ESP32. Now double check your connections according to the circuit diagram before powering the circuit. Now download the code and library files given in the description below. Open the code and library files if you already downloaded the Arduino IDE, otherwise download the Arduino IDE first. Include the required libraries: Wi-Fi.h to connect ESP32 to Wi-Fi, Where.h for I2C communication used by the OLED, Adafruit_SSID1306.h controls the OLED display, WebServer.h hosts a web page that shows parking status, ESP32 servo.h controls the servo motor, better for ESP32 than servo.h, defines the OLED resolution, creates a display object with I2C settings where IR_entry and IR exits are connected to IR sensors. Servo_pin is for the servo controlling the barrier. A servo object is created to operate the gate, replaced with your actual Wi-Fi name and password. Create a web server on port 80, which is the default HTTP port. Now these are the variables: total slots, which is the total parking slots, available slots, which change dynamically, flag entry or flag exit, used to prevent multiple triggers from one variable, setup function starts serial communication for debugging, sets IR sensor pins as input, connects and sets servo to close 90 degree. Initialize the OLED at I2C address 0/3C. If it fails, the ESP32 stops. Clear and updates OLED with initial info. Tries to connect to Wi-Fi. Prints dots while connecting. Print success and IP address. Create a very simple web page. Display a current available slots. Now starts the servo. Loop function listen for web page request. If a car is detected by the entry sensor and not already processed, if a slot is available, it open gate, close gate, reduce count. If not, then show parking full. When sensor goes high again, ready to detect the next car. If exit sensor detects a car and has not already triggered, it increases available slots. Open or close gate. This clears the screen and shows updated slot count in large text. temporarily shows parking full message if no slots are available. And that's it. Now we will upload the code to the ESP32. Plug your ESP32 into the computer using the USB cable. Select the correct port, ESP32 dev module. Then go to the tools and select port where USB32 is connected. Make sure to replace the Wi-Fi name and password here. Now click the upload button. If you see connecting and the dot appears, just hold down the boot button until it starts uploading. Once uploaded, open the serial monitor and set the baud rate to 115200. You will see message like connecting to Wi-Fi, and then Wi-Fi connected and IP address will be displayed. Note down the IP address. Open your device's browser, type the IP address in the address bar in any web browser on the same Wi-Fi network. A neat web page will open and the project title ESP32 parking system along with the current available parking slots. You can now test the IR sensor. Put your hand in front of the entry IR sensor and the barrier will open if a slot is available. The OLED screen updates in real time with parking slots. When all slots are full, the OLED displays parking full for 2 seconds. And that's it. If you like this project, don't forget to like, share and subscribe for more exciting tech projects with Roboarmy.